Hello everyone, welcome to a series where we were writing bootloader from scratch. In this video, we are going to continue from our previous video. In the previous video, we were in protected mode, and one thing to say is that uh, there were some uh, typos in my previous code, so I'm gonna just show you guys so you can just fix it. So these are the typos. So first of all, you need to, I forgot to write the B on the last of this byte, same in this data section. And also it should be GDT, not GTD. And also in line 55, in line 59. I'm gonna quickly correct it. I hope you guys correct it. So let me first uh, erase this and write GDT, GDT, and GDT. And now we need to define here B and B so that it doesn't give any error while we try to compile it. Okay. Now, uh, in this video, we are trying to go to long mode, but before we go to long mode, we need to keep in mind that we need to first of all enable the physical address extension bit in the control register in the CR4 control register, and after that we are going to set up the page table and then load the global descriptor table and then enable the long mode, and eventually after that, if everything goes as planned, we will jump to the uh, long mode. So that is the plan for today's video. But what I'm trying to do in today's video is like I will write code for calling uh, calling a function so that we can implement the thing, but I'm not going to write the entire function and also for implementing the entire global descriptor table in today's video. I feel like if I do so, it will be too much long, and I don't want to make the video too long. It is already too long. So let's jump into it. So first of all, what we need to do is we need to enable the PAE flag in the um, control CR for control register, and afterward we will see. Okay, so I'm gonna move whatever the content is in the CR for control register to EAX. Okay, CR4. Now we need to set the flag. So we need to find which bit is the a flag that sets up the PAE. So as far as I remember, it is the bit number 5. So we are going to do OR with that value. So that means we are going to do OR EAX with 0x 0 and 1 over here, and 1 2 3 4. So that means it will do exclusive or with the value, and then afterward we are going to place that value into the control register again so that we don't modify anything. So move CR4, the value that we modified. Okay, now we have set up the mm, PAE. Now we can implement the paging. So here I'm gonna write something uh, that you will guys understand in the next video. So call, this is I'm calling a function that we will write in the next video. Set up 3, the value of. Now you might be wondering what is PML4. So we are going to define it over here. So PML4 EQ equals to 0x1000. So in hexadecimal, this representation means 4096. That is the size of one table. It should have 512 entries, and each entries is like 8 byte. 8 bits. Yeah, no, no, it is 8 bytes. So that's why we got 4096. You will understand later in the next video. So let's see. So we have mm, call the setup paging, and also after that we have uh, I think we cannot just write into the control register with constant. So we need to first, I think we need to do this first EAX. Okay, and afterwards move CR3 to have the value of EAX. Now that we have implemented PAE, and after that we have implemented paging. Like we have virtually implemented paging, not actually, but we have done the skeleton part. We will do the bone part. We will do the remaining part later. Now we need to enable the long mode in the EFER register. Its full form is extended feature enabled register. So no, CPU has many hidden register, and this register is also hidden. So we need some instructions to access it. So we are going to use read modified sorry, read model specific register. So what this instruction does is we put a value in ECX register, and it will be used as a selector, and it will put the value content of that EFER register into EAX register. So after that we can do OR with the bit that we want to set, and then we're gonna use write model specific register, and then we're gonna write again back to the EFER register. So that is the plan. Okay, so let me comment this out, and this and this. uh so the value that you need to put in the selector is 0x8000 and 00 and 80. So what I'm saying is, like, let me show you visually. Move ECX to contain the value of 0x C 000 and 0080. So this points to this EFER register. So using the read model specific register, the value will be stored in EAX register. So we want to set the bit number 8. We want to set the bit number 8 of this register. So what I'm gonna do is I'm gonna do REAX 1, and we're gonna shift it 8 times. So with this being said, we have already done it. And we're gonna again write back to the write model specific register. Now that with these 4 lines, we have set the long mode. Now we want to load the global descriptor table, just like we did over here. But this was for, like, you can see this was for like a 32-bit mode, but we want to load it for the 64-bit. So I'm gonna just copy it, and later in the next video we are actually going to define it. But for the sake, uh, I'm gonna just rename it using GDT 64, like later we were gonna define it. And now that we have done it, now it's time to enable the paging, the final boss. Enable the paging, and to enable paging we need to set up bit 31 uh, of CR0 register. So same game again, move EAX to have the value of CR0 and do OR with EAX and 0x 80, this being 8, this being 16, 24, and this being 32. That means the 8 will be 1000. That means the bit number 31 will be 1. That means the 31 bit will be set, and then we're gonna again write back to the CR0, that is CR0 to contain the value of EAX. Now that uh, everything is done, what we want to do now is we want to jump to the uh, uh, long mode. That means the code offset, if you can see the code offset here, oh sorry, the code offset over here is equal to like this distance from start to the code part. But if you like see uh, for the 64 descriptor table, the offset will be same. So I'm gonna use the same code offset because it gonna be same, and here I'm gonna write uh, long mode. Okay, and later in the far bottom corner, in the far bottom, I'm gonna make a label called long mode, and here we are going to use the long mode we are going to use 64-bit instruction offset data and everything. And let me use this directive to tell the assembler that we are going to use 64 bits in everything. And one thing is that after we have implemented paging, now every address will be addressed using virtual memory. So we don't need to use segmentation the trick like previously. As you can see, we used AX2 has the value of data segment, and in the real mode we use AX to have value 0, and like we don't need to do anything, we just can ignore it. Segmentation is just for protection in long mode. The actual memory addressing is used by paging. So we're gonna define it later in next video. But uh, in the next video, what we will be doing is we're gonna first define the 64-bit descriptor table. And is if I haven't told you, it will be like really easier because we have already done 32-bit descriptor table, and it is like very much similar. So it will be easier. And the difficult task is to write this setup paging function, because like writing it is very much easier because it is only like 6 or 7 lines, but understanding it to the depth and knowing what is happening is another task. And we are also going to see why we don't have like one level of paging, why there is not one big table which maps the frames to the pages. So why we need uh different level of tables, like level of paging, in the next video. And we're gonna answer all those questions in the next video. And I hope you guys enjoyed today's video and understood what I was saying. So see you on the next video. Thank you. Have a good day or good night.